This is the largest fish collector system at a hydroelectric project in North America, and the only structure of its kind in the world. It was built at Portland General Electric's Round Butte Dam in Central Oregon to provide the first passage for downstream migrating salmon and steelhead in almost half a century. The giant structure, 273 feet, top to bottom, is taller than the utility's downtown Portland, Oregon headquarters, and only 30 feet shorter than the Statue of Liberty. The floating 13,500 square foot fish collection top structure weighs 5 million pounds, a third of an acre, floating on concrete pontoons. Round Butte Dam is part of a 3-dam system on Central Oregon's Deschutes River, PGE's Pelton Round Butte hydro project. Generators can produce 465 megawatts of electricity for PGE customers. Completed in 1964, the 440-foot-high earth and rock-filled structure holds back 3 rivers, forming Oregon's most popular outdoor recreation destination, Lake Billy Chinook. Pelton Round Butte is also the only hydro project co-owned by a Native American tribal organization and an investor-owned utility. Innovative cooperation between the two owners began even before the first material was excavated from the steep Deschutes River Canyon.
Generally, from a tribal's perspective, Warm Springs tribe or any other tribe, fish, as rare as they are now in modern context, tribes don't want to see them becoming a museum piece. They want to have these fish and they want to use them for their cultural, their subsistence, and their ceremonial uses forever.
Tribal members, PGE, and government representatives would come together 40 years later to relicense the project. The selective water withdrawal structure is the dramatic centerpiece of that relicensing plan.
The heart of the settlement agreement we're signing today is a plan to protect and restore tribal and endangered fisheries and wildlife habitats in the Deschutes River Basin. The challenge was to accomplish this while continuing to provide the vital, low-cost power produced by the Pelton Round Butte hydroelectric project.
We made a promise to minimize the project's environmental footprint, and the real way to do that was to pass fish over Pelton Round Butte, even though it's a high-head dam. It was clear from the beginning it was going to take truly innovative engineering, truly innovative biology, and top-notch science all the way around.
In 2005, PGE and the Confederated Tribes of Warm Springs established a $21.5 million fund to support environmental protection measures and maximize fish survival both upstream and downstream of the dams.
The selective water withdrawal structure and the relicensing process has really been a catalyst for local restoration. It's galvanized the community, it's brought people together, it's created a vision for all of us to work toward. And I think it's just a very exciting process to be part of.
The idea was to reintroduce salmon and steelhead in the upper Deschutes Basin and restore more than 226 stream miles to fish. The Chinook, sockeye, and steelhead that will return to these upstream improvements will be the first to pass PGE's Round Butte Dam since fish passage efforts were discontinued in 1968.
The reason that this didn't work the first time was they built this dam with a deep withdrawal. The water came into the powerhouse from the bottom part of the reservoir. So anyway, the downstream migrant fish that are keen on the surface currents were keen on very confusing swirling currents that ebbed up the Metolius arm and couldn't find the dam and couldn't find their way out of the reservoir.
The new structure, designed to solve the problem, towers 25 stories above the existing underwater intake at Round Butte Dam. The whole river travels through the new structure to the submerged intake, creating surface currents where the fish travel, attracting them to the facility where they can be collected and sorted. The fish that should go to the ocean are transported downstream of our 3 dams to begin their journey. The structure is the first of its kind to couple fish passage with selective withdrawal solely with powerhouse flows. The surface withdrawal will keep the reservoir cooler in the summer, creating a healthier environment for fish in the lake. The bottom structure draws cold water during summer and fall to mix with warmer surface water, allowing appropriate downstream temperatures in the lower river.
As we were looking at what our requirements were going to be here to pass fish using surface currents and to also make sure that we could pass water sufficiently to meet our water quality requirements, we decided to take a very comprehensive look into what has been built out there ahead of us. And as we looked into the literature, we looked through internet sites, We found out at that point that we were on our own.
A test model was built and operated at a special hydrology lab near Seattle. The model was put through extensive water flow scenarios, and modifications were made to the concept through a 2-year hydraulic test period.
The contractor will be building this structure on floating barges. They'll be building this above the water, and then once the structure is erected, they will sink the bottom structure into place 260 feet deep rather than building a cofferdam to build this structure at that depth in the dry.
While construction of the top structure, vertical flow conduit sections, and bottom structure continued on the east side of the dam, underwater work was underway excavating the rock at the lake bed to receive the 1.4 million pound bottom structure.
A lot of the excavation was done with drop hammer and chisel, and we were able to do that without divers because we had the remote operated vehicles to tell us what we needed to remove. We had sonar and GPS to tell us our coordinates to make sure our excavation area was wide enough and in the area we needed to work on, and that the bottom structure, when we brought it in, would fit in the location we needed to put it.
In August 2008, the top structure, the part that floats, began to look like the drawings. Finally, the bottom structure, the vertical flow conduit, and the floating top structure were moved into place. In December, the selective water withdrawal structure, now attached to the shore by the access bridge, became operational. Even while PGE engineers and hydraulic consultants made adjustments, fish were attracted to the currents and were appearing in collection tanks.
These smolt are actually going to return to our adult trap at River Mile 100, approximately like this size.
By 2012, the adult salmon and steelhead should begin their return trip from the Pacific up the Columbia and Deschutes. They'll be captured at the lower dam, then trucked upstream past the dams to complete their life cycles for the first time in more than 40 years.
When we decided to build the Selective Water Withdrawal project and move forward on that project, we didn't know if we could do it. So it really took a fair amount of risk from the company as well as the risk from the agencies to trust that we could make this work. And I will tell you, it was that collaboration with all the parties that made that project successful.
The kind of collaborative approach used here is one that it really does set a great example of leadership on how these issues can be resolved.
I have been getting contacts from all over the world about this project, so it's not being watched just nationally but also on a global basis.
It's great. You know, I think we couldn't be happier. We couldn't leave a better legacy behind us in terms of the outcomes of this relicensing and the presence of the SWW on the Deschutes.